So the next part is we have discussed in the last class the batteries. Okay, what are batteries? They are all electrochemical cells which convert chemical energy into electrical energy. It's basically we discussed lithium-ion batteries. Okay, next we'll discuss the fuel cells. There are also electrochemical cells. Um, was first discovered by a British judge, William Grove, Sir William Grove. The research on fuel cells got importance as the conventional energy sources are depleting, and also for the reduction of emission of greenhouse gases. Okay, the greenhouse gases means which right, carbon dioxide and all. With the conventional energy sources, okay, petrol, diesel, and all, what they emit, vehicles emit the carbon dioxide and all. So to avoid that, the fuel cells are expected to play a vital role in the future energy scenario, particularly when hydrogen is projected as the main energy source of 21st century. Now what we are doing, we are projecting hydrogen as energy source, main energy source. See, the production of hydrogen is very simple, right? So you require a container, and you take water with some salt, take two electrodes which are covered with, imagine your cold drink bottle. Okay, in that you are inserting electrodes. Okay, anode and cathode. This is anode. Okay, this is cathode. Then you connect it to a, okay, voltage. Okay, battery, connect it to a battery power supply. At cathode, what happens? Hydrogen evolution takes place, right? How water splits? Water splits into oxygen, O2 plus 2H2, hydrogen gas. Okay. Now people are talking about oxygen production. You might have heard about oxygen, right? Problem is there, kerosene cylinder, we require something. So you can use this technique. Okay, at anode, what happens? Oxygen is produced. At cathode, hydrogen is produced. You collect it somewhere else, right? Storage of hydrogen is very difficult. Okay, you have to take it out. Okay, fuel cells, we use the hydrogen gas and we supply it to the anode here. Okay, anode of fuel cell. Okay, at anode, what happens? Oxygen evolution takes place. Okay, for this fuel cell, you can use that oxygen produced can be used here as oxidizing agent. Okay, oxidant. Okay, so what are fuel cells? Fuel cell is a galvanic cell. What is a galvanic cell? A cell which produces electricity, where chemical energy is converted into electrical energy, in which the chemical energy contained in a readily available fuel oxidant system is converted directly into electrical energy by means of electrochemical processes. Okay, so the fuel cell essentially consists of following arrangement. It consists of, see, this is the fuel cell. Okay, it will be like this. Okay. One electrode, another electrode. Two electrodes are there. This is anode. Okay, anode we pass what? Hydrogen gas, fuel. At cathode we pass oxygen. Okay. When hydrogen comes into in contact with the electrolyte present here, okay, diffused through this electrode, it forms H plus ions, two H plus ions, and these ions they migrate and they react with oxygen forming H2O. What is the product from H2O? So at anode, oxidation of fuel takes place. Hydrogen undergoes oxidation. Fuel undergoes oxidation. Okay, for example, hydrogen if I take 2H2 gives 4H plus. To balance the charges, you need to write 4 electrons, right? 4 electrons are released at anode. So these electrons are pumped to the external circuit. Through the external circuit, you can measure the voltage here. It will be 1.23 volt. Open circuit voltage is 1.23 volt. At cathode, reduction of oxygen takes place. At cathode, what happens? The oxygen O2 accepts the two electrons coming from anode, okay, through the external circuit. It accepts the electrons here coming from anode and also takes up the H plus ions coming from the anodic, they are diffusing to the anodic electrode. So 2H plus, it gives H2O at cathode. Yeah, H2O comes out. So unreacted oxygen also comes out here. Right. This is the working of any fuel cell. Oxygen accepts the n number of electrons coming from anode and reduction products. Reduction product is water here. Oxidized product is 4H plus ions. Okay. So what is a fuel cell? Fuel cell is a galvanic cell in which the chemical energy contained in a readily available fuel oxygen system is converted directly into electrical energy by means of electrochemical processes. So what is the difference between a battery and a fuel cell? You might have observed batteries, they store chemical energy, lithium ion battery or something. They can store the chemical energy. Okay, whereas fuel cells do not store chemical energy. You need to supply the fuel and oxidant. You need to supply what? You need to supply fuel and oxidant. Then only it works. Okay, from outside the cell. Okay, the cell doesn't contain any chemicals. Only electrolyte will be there, but the oxidants and reductants are supplied from outside. Reactants are supplied from outside. Oxygen from right from cathode, hydrogen or the fuel from anode. Okay. The electricity is generated till the active materials exhaust. Okay, in the cell. Okay, here electricity is generated as long as the fuel and oxygen are supplied from outside. As long as you supply fuel and oxygen, this cell works and it produces 1.23 volt. Okay, whereas battery continuously works. Okay, it doesn't require the external uh, supply, fuel and oxygen supply, but batteries need to be charged, right? As and when the battery, what happens to the battery voltage decreases, right? And after some time it needs recharging. Okay, here recharging is not required for fuel cells. Batteries usually contain toxic compounds like lead, cadmium, etc. and all. Okay, therefore, these fuel cells are eco-friendly since no toxic chemicals are produced. You are using hydrogen and oxygen, and the product formed is water. So all are benign, all are environmentally friendly. So it's eco-friendly. Okay, you know the difference between battery and the fuel cell. Polymer electrolyte membrane fuel cell, proton exchange membrane fuel cell. So right, we have studied this in first year B also, but little bit detailed explanation is there here with nanotechnology part involved in this. Okay, there you are not studied any nanotechnology in fuel cells. The polymer electrolyte membrane fuel cell is also known as proton exchange membrane fuel cell. Okay, both mean the same. PM, some people call polymer electrolyte membrane, some people call it as proton exchange membrane. Okay, proton exchange membrane is basically made up of Teflon. Teflon, where you use it? Use it in your non-stick cookwares, coating, anti-corrosion coating on your two-wheelers. Teflon is used. Many electrical applications they use Teflon. Right, Teflons are used in for blades in fans. Okay, many applications are there for Teflon. Teflon is also used as lubricant. It has got hydrophobic property and it has got lowest coefficient of friction. So Teflon is, what is Teflon? Poly tetrafluoroethene. Okay, what is Teflon? It is polytetrafluoroethene. You know that. Okay. What is this? Polyethene, CH2, CH2. Okay, double bond was there. Okay, once it is polymerized, it is removed n times. It is what? Polyethylene. Instead of CH2, 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 if it is CF2, CF2, then it is called PTFE, polytetrafluoroethene. Okay, if you sulfonate it, okay, sulfonation of this, okay, you are attaching SO3H group, sulfonation, okay, makes it proton exchange membrane. Proton exchange membrane, whatever we say, it is sulfonated Teflon. Okay, that is the membrane used in fuel cells. Okay, sulfonated Teflon it is. Okay, you know it. You have studied in B first year. Water-based acidic polymer membrane, that is Nephyon membrane. Okay, sulfonated Teflon is known as Nephyon. Sulfonated Teflon is known as Nephyon, NaFiON. Okay. Electrolyte is sandwiched between two electrodes. Okay, Nephyon membrane is nothing but sulfonated Teflon. It is sandwiched between two electrodes, anode and cathode. At anode, hydrogen is used as fuel, and at cathode, oxygen is used as oxidant. Okay. Proton exchange membrane fuel cells operate at relatively low temperatures. Okay, temperature usually below 100 degrees Celsius. The electrolyte allows only hydrogen ions to pass through it. Okay, not either electrons or hydrogen gas. See, this Teflon membrane allows only the hydrogen ions, not hydrogen gas. It blocks that hydrogen gas reaching cathode. Okay, for example, if it reaches cathode, okay, this hydrogen gas itself reaches at cathode, oxidation takes place here. When oxidation takes place here, no electricity is produced. We want oxidation to take place here because electrons should be released at anode. Okay, reduction should take place at cathode. Is that clear to you? Hydrogen fuel is supplied at anode where oxidation of hydrogen takes place and electrons are liberated. So hydrogen ions, H plus ions, pass through the electrolytic membrane towards the cathode and electrons are moved to external circuit. On the other hand, at cathode, oxygen is passed, which undergoes reduction with the formation of water. So this is what is happening. Okay, hydrogen you are supplying here, oxygen you are supplying this side. Okay, so hydrogen, what happens? Hydrogen adsorbs here and it penetrates through this electrode, anode, and it goes as hydrogen ion. It passes through this. What is this? PM cell, PM electrolyte, proton exchange membrane. It is nephron. Okay, it passes through that and it reaches cathode. Once hydrogen ions reach cathode, okay, first hydrogen ions are produced. Okay, at anode here ions are produced and electron is released. Electrons released, they are pumped to external circuit. Okay, and they are taken up by cathode. Okay, and these H plus ions, two H plus ions, two H plus ions, which are produced, they migrate to cathode and they react with the oxygen. Okay, the oxygen and forming water molecule. This is the reaction. Okay, overall reaction is very simple. Hydrogen plus half oxygen giving H2O. Okay. So important in PM fuel cells. Okay, as an engineer, we have to think about the construction. Okay, that is the basic theory what I discussed earlier. Okay, how they are constructed. Okay, what do you require? You require current collectors, not just the electrodes. You require current collectors. Anodic current collector usually it is copper. Remember, and cathodic current collector usually it is aluminum. You remember this. Okay, these are the aluminum plates. Okay, on that what we coat the catalyst. Okay, so these current collectors, okay, there is a right, what do you say, there is a air gap, okay, so that hydrogen can be passed, and when it is passing through this one, it is in contact with the electrode itself, not the current collector. At one end, the other end current collector is there. Okay, air, instead of air I can write oxygen itself. Okay, is supplied at cathode. Okay, this is proton exchange membrane, PEM. Okay, so we use some catalyst like platinum catalyst. Usually we use platinum, rhodium, platinum, palladium catalysts are used. This is platinum catalyst. Or you can use carbon impregnated with platinum. Okay, platinum, palladium, and platinum, rhodium catalysts. Okay, for oxidation and reduction. Palladium is used for oxidation. Rhodium is used for reduction. But cathode, polymer, right? Platinum, palladium is here. Platinum, rhodium is here. So oxidation reduction. They help in oxidation and reduction. Okay. So what is the role of gas diffusion layer? So fuel. See, this is how it works. See, this is your gas diffusion layer. Homogenize, what is the role? Homogenize the gas flow. Catalyst layer controls the water flow, maintains water content of the right cell suitably. These are the functions of gas diffusion layer. They may ask you in the examination, what is the role of gas diffusion layer? Okay, and what is the role of proton electrolyte membrane? It allows hydrogen ions pass through, permeate through it, not the electrons or hydrogen gas. Here we coat it with catalyst. Okay, usually platinum ruthenium alloy is also used. Okay, so this is carbon and we coat it with platinum or platinum ruthenium catalyst. Ruthenium is also right, oxidation catalyst. Okay, palladium can also be used. Ruthenium can be used. Palladium can be used for oxidation. Okay, and right, reduction also. Here ruthenium is used as both, for both. Okay, right, palladium is usually used for oxidation. Okay, doesn't matter. We use platinum catalyst. Okay, separator forms passage of the gases. Okay, right. This is separator. Right. This is fuel cell electrode anode. It is air electrode means it is cathode. Right. Catalyst. What is the role of catalyst? Catalyst accelerates the chemical reaction on both the fuel and air electrodes, fuel and oxygen electrodes, anode and cathode. The important is gas diffusion layer. The gas diffusion layer plays several critical roles in a typical fuel cell application. It is often integrated as a part of membrane electrode assembly. Okay, here it is. Okay, this is gas diffusion layer. This is the gas diffusion. Why we use gas diffusion layer? One, it homogenizes the gas flow. Okay, if it is not there, for example, directly, if it is not there, the gas will come in contact with this. Okay, all the gas may enter here. There is no gas here. Okay, or again it may enter here. So it is not homogeneous. To homogenize that, we use this gas diffusion layer. To the catalyst layer. Okay, controls the water flow and maintains water balance. Okay, it also controls the water flow and water balance. Here, water is produced at cathode, so it has to be drained out. So that's another role of this gas diffusion layer. Okay, and it also maintains the water balance. So what does gas diffusion layer consist of? Gas diffusion layer is a porous structure made up of weaving carbon fibers. Okay, we use carbon fibers into a carbon cloth. So basically a cloth, carbon cloth. By pressing carbon fibers together into a carbon paper. What do they take? They take carbon paper and they press carbon fiber on it and they make this gas diffusion layer. Many of standard GDLs mean gas diffusion layers that are produced today come with a microporous layer, okay, MPL we say. Okay, so it's very thin layer, okay, and hydrophobic treatment means they give Teflon coating on that surface. Okay, hydrophobic, so that water will not is retained here. Okay, it repels all the water. Okay, it will remain dry all the time. MPL, okay, and PTFE, polytetrafluoroethane, that's Teflon. Okay, help with that. They help the contact to the membrane with water management. Okay, it helps in the water management. Okay, and it also helps in contact with the membrane. Okay, the MPL typically provides a smooth layer with plenty of surface for catalyst and good contact with the membrane. Okay, it provides smooth layer and plenty of surface area. It gives a lot of surface area. Microporous are surface is microporous. There's a lot of right gases can absorb and they can pass through. And MPL often uses PTFE as binder that increases hydrophobicity, as I mentioned earlier, which helps to keep the water within the membrane from escaping or drying out the membrane, causing higher resistance. There is often an additional PTFE coating on MPL surface to further augment this. The same thing. Okay, to further augment this, there is an additional coating of PTFE on MPL layer. There are some problems with PM fuel cells. First is its cost. Okay, so there is an estimation. Okay, fuel cell system costs 4,200 rupees per kilowatt. Right, assuming the volume of production is 1 lakh automotive units per year, and approximately 3,700 per kilowatt that could be achieved if it is 5 lakh units per year. Okay, so it's costly. Okay, the battery costs you around say 200 rupees or 300 rupees lithium-ion battery, but these cost you like anything. Okay, thousands. Many companies are working on techniques to reduce the cost of a variety of ways, including reducing the amount of platinum needed in each individual, because platinum is very costly and it's precious. It's not available. It's available only in Africa. Okay. Ballard Power System has experimented with catalyst enhanced with carbon silk. They use carbon silks which allows 30% reduction, a 1 milligram per centimeter to 0.7 milligram per centimeter in platinum usage. They reduce the usage of platinum catalyst and they use carbon silk without reduction in performance. Monash University, Melbourne uses PDOT, poly, polyethylene dioxythiophene, as the cathode. Okay. The first metal-free electrocatalyst using relatively inexpensive dope carbon nanotubes, which are less than 1% of the cost of platinum. Now people started using metal-free electrocatalyst using in a doped nanotubes, carbon nanotubes. Nanotechnology comes into the picture now. Okay, right, and are of equal or superior performance. Okay, compared to platinum electrode. Okay, a recently published article demonstrated how the environmental burdens change when using carbon nanotubes. What are carbon nanotubes? Okay, you take graphite, single layer of graphite is graphene, roll into a tube, it is carbon nanotube. Remember this. Okay, there are many methods to make that carbon nanotubes. Water and air management. There is another problem with polymer electrolyte membrane fuel cells or protonation membrane fuel cells. In this type of fuel cell, the membrane must be hydrated, requiring water to be evaporated at precisely same rate that it is produced. If water is evaporated too quickly, the membrane dries, resistance across it increases. Okay, when it dries, okay, what happens? The resistance definitely increases. Okay, even eventually it will crack, creating gas short circuit where hydrogen and oxygen combine directly and generating heat that will damage the fuel cell. If the water is evaporated slowly, the electrons will flood, preventing the reactant from reaching the catalyst, stopping the reaction. Methods to manage water in cells are being developed like electro-osmotic pumps. Okay, people are using electro-osmotic pumps, focusing on flow control. Okay, just as combustion engine, a steady ratio between the reactant and oxygen is necessary to keep the fuel cell operating efficiently. Okay, if you don't remove the water, or if you if you remove all the water, there is a problem. So then this requires diffusion pumps, osmotic pumps we say, electro-osmotic pumps, where they use silver chloride electrodes and all those things, right? So that's not required for your this one, right? But you should know water and air management is an issue, in right, is an issue in polymer electrolyte membrane fuel cells. Temperature management. The same temperature must be maintained throughout the cell in order to prevent destruction of the cell through thermal loading. This is particularly challenging as hydrogen reaction with oxygen is highly exothermic. So large quantity of heat is generated within the fuel cell, and then that you have to manage. That needs to be managed. Durability, service life, special requirement for some type of cells. Stationary fuel cell applications typically require more than 40,000 hours of reliable operation at a temperature of minus 35 to plus 40 degrees Celsius, while automotive fuel cells require 5,000 hour lifespan, equivalent to 240,000 kilometers under extreme temperatures. Current service life is 2,500 hours, about 120,000 kilometers. Automotive engines must also be able to start reliably at minus 30 degrees Celsius and have high power to volume ratio, typically 2.5 kilowatt per liter. Limited carbon monoxide tolerance of some non-PDOT electrodes. There is another problem. So nanotechnology in fuel cells. Unless you have very high temperature, platinum is needed as a catalyst, which is very expensive, and 80% of which is found in South Africa. Hydrogen has lower energy per volume than, for example, gasoline. So which means that one requires practical storage system. See, The main problem with fuel cell is storing hydrogen. Can you imagine you are driving a car and next to you is a hydrogen cylinder? It's very dangerous, right? So that is another problem. Storing of hydrogen is very important. So there's a practical problem. Hydrogen cylinders, if they explode, it's like hydrogen bomb. So there are graphene cobalt catalysts. Graphene is a single layer of graphite. It's a nano sheet. The cobalt nanoparticles on a single layer of graphene can be used instead of platinum, which is much cheaper. Okay, lower costs due to cobalt being vastly less expensive than platinum. There are so many nanoparticles nowadays they are using. This is one of the example I'm giving you. Graphene cobalt catalyst. Right. So graphene cobalt catalyst also degradation is also slower. Okay. Graphene hydrogen storage. Single sheet of graphene cannot store hydrogen well. Okay. Layers of graphene oxide can store a large amount of hydrogen. Okay. So graphene oxide has to be prepared. Okay. Also useful in releasing hydrogen when needed. Of course, not only storing, you have to take out that hydrogen. That's another issue. Okay. So this graphene technology is being developed to store hydrogen. Okay. This is about the fuel cell. If you have any questions, you can ask me. Yes, any questions in hydrogen, oxygen, fuel cell? Fuel cells. What are fuel cells? Yes. The fuel cells are basically galvanic cells in which the chemical energy contained in a readily available fuel oxygen system is converted directly into electrical energy by means of electrochemical processes. Okay. A fuel cell essentially consists of a fuel, electrode, that is anode, electrolyte. Electrolyte used, okay, we know various types of electrolytes are used in, they studied it in first year itself, but for this nano syllabus, we have only proton exchange membranes we have kept because that is presently we are using. Okay. Uh, then it is connected in contact with the cathode and then the oxygen. Okay. Any questions you have, just ask me. Okay, I'll just uh, go through this. Okay, differences between battery and fuel cell. Any questions on this? Right. Polymer electrolyte membrane fuel cells, proton exchange membrane. Okay, I discussed this. Okay, how it works. Okay, what is the reaction? Hydrogen giving H plus ions plus 2 electrons. This is what we are using present day, product for production of oxygen. Right. Not this reaction. The reverse of this. Okay, H2O giving half O2 plus hydrogen gas. Okay, so electrolysis. Okay, what is the role of gas diffusion? In the examination, they may ask you to explain the role of gas diffusion layers. Okay, construction of PM fuel cell. Gas diffusion layers. Okay, so why do you? All right. What it consists of? How it is made up of? Write a note on the gas diffusion layer. Okay, you have to write everything. Okay, you can draw this diagram and explain. This much is enough. Okay. Design issues, if they ask, we have to write all these things. Okay. Nanotechnology in fuel cells is basically for hydrogen storage we are talking about and catalysts. Okay. Graphene oxide is used to store hydrogen. I'll stop here. If you have any questions, you can ask me. Otherwise, just type your name and your USN for recording attendance.